This is a little demonstration of how to use the revolution of the moons of Jupiter, a Project CLEA exercise. I'm going to begin by logging in. Once you've logged in, you can begin the exercise by clicking on File and then Run. In the Set Date Time box, you can start off any time or day that you wish. In the lab instructions that I've given you, you'll see the specified date and time. I'm just going to start with today's date. I'm also going to make a change to the timing because I'm going to observe every 4 hours for the purposes of this demonstration. You'll use a different time interval. You can see the date interval is down here. There's the time under the universal time. And I'm going to only look at the innermost moon of Jupiter, and that's Io, which is right here next to Jupiter. And since I'm only looking at the innermost moon, I can go ahead and use the 400x setting. You'll notice this moon out here, which is Callisto, is going to disappear when I do that. And only 2 moons are visible. So this moon, I'm going to guess is Io, but I can find out by clicking on it. And in fact, that's incorrect, which is fine. So I'm going to guess this moon is Io. And then when I click on it, I see that I am correct. And then I wish to record the data for this moon. You're going to want to record for all the moons. I'm only going to use Io. So there's the information for Io. It's at 2.58 Jupiter diameters west. Now keep in mind a Jupiter diameter is the distance across Jupiter. And we use that as a reference scale for our measurements. And then later on, you'll actually convert that. Once I've made my observations, and again, I'm only doing Io, I'll click the next button, and I'm thinking this is Io here. And if I'm incorrect, it'll tell me, but it's not. So I'll hit record again, click on OK. You'll notice only 4 hours have gone by. It's still February 1st, 4 hours. And I think this might be Io, and that's correct. So I record, and you're seeing that I'm going to do this over and over again. Okay, I've gone ahead and collected quite a bit of data. So now I want to make sure I've got it all. So I'm going to go to Data, and then click Save. And I'll go ahead and save it in a binary format. Now this CSV format, if you need to send me the data, that's the type of file that you want to send to me. You can always put that into a spreadsheet, but we'll go ahead and use the binary format. Then here's the data, JupSat data, and it'll save it in a subdirectory that it creates. Remember, I logged in as Paul, so that's the subdirectory it creates. And I'm just going to change this a little bit and put 2_1 for February 1st, since that was my start date. Now if I was to have left and come back, I could always load the data using that same format. So let me actually go ahead and exit. We'll start this back up again. Log back in. Run the program. I'm going to go ahead and load my data. And then I want to analyze the data. So go to File, Data, and then down here at the bottom is Analyze. I need to select the moon. So under Data, select Moon. You notice only Io is highlighted. The other 3 don't have any data. And there's all the data that I have. You can kind of see a nice up and down function. That's what we call a sine function. So I need to fill in some information. So I look at this peak here, and each of these notches is 1 day at the bottom. So 689, 690, 91, 92, 93, etc. And each of these represents, in this case, 1.5 Jupiter diameters. I go to Data, Plot, Fit Sine Curve, and Set Initial Parameters. My 0 is where all of this is going to start, and so it's pretty close to 689. Doesn't need to be exact. The period from here to here looks to be about 2 days, because here's one, here's another one, so from here to here is 1. This is a little wider, so I'm just going to go 2. Don't need to be exact. And the amplitude is from peak to peak, and so from the middle 0 to the top is 3, to the bottom is about -3, so the amplitude is 3. And I click on OK. And you can see that this blue wavy line needs to be moved a little bit. So I'm going to move it to the right, and that's done by adjusting here. But you see, as I move it to the right, these guys are starting to fit nicely over here on the left, but over here on the right, they're too far to the right. And what that tells me is that this distance is too wide. So I need to squeeze it. That's by changing the period. I can squeeze that by altering the period. You'll see my RMS residual over here is green, but if I alter the period too much, it becomes red. I'll go back to green. Somewhere in there looks good. Looks to me like I want to give it another shift to the right. Maybe too much. Now, if it comes to the point where you've moved this too far to the left and you can't go any farther, when you click on this right here, that automatically recenters it. So if I shifted this to the left and click this button, you'll notice my adjusting slider here has moved back to the middle. Do the same thing on this top one. Moves back to the middle. You want this number, the RMS residual, to be as close to 0.1 or smaller as you can get. And this is 5.796. Over here, this E negative 0.1 means times 10 to the minus first. So that means this is, move the decimal place left 1, this is 0.5796. And I can do better than that. And you want to do better than that. You want to get down to 1 point something. E negative 1 or E negative 2 would be even better. Once I've gotten that information, I'm interested in the period here in days. Okay, that is the time it takes Jupiter's moon, Io, to go around Jupiter. And according to my graph, and it's not very good, but I'm going to leave it there, this is going to be around 1.92 days, 1.93 days. The amplitude here is about 3. I have not yet adjusted it, but I can adjust it. I can make it smaller or larger. Okay, and you'll notice here it's around green again, and that's what I want. I want green. Right now I'm doing a coarse adjustment. If I slide this over here, then these adjustments you can see are not quite as big. Fine adjustment is when you really get down to where the 5.8 here is even smaller. Once you get to really fine tuning it, you want to go to the fine adjustment. But for now, the coarse adjustment gives you a lot more control. Okay, and that's how you adjust your controls. Again, the period is one piece of information that you want, right down here in the lower right corner. And the amplitude, also in the lower right corner, is the other thing you want. That's what we call the semi-major axis for the orbit of Io, or whichever of the 3 moons you're looking at. Semi-major axis. And this is the period. And you're going to use those values to calculate the mass. I've also included a spreadsheet to help you with those values. Here's where your period would go for Io. This would be about 2 days. I just put ones in so that there's something calculated. You're going to change those to whatever numbers you get. Here's your semi-major axis in Jupiter diameters. I've set it up so these columns are automatically converted for you. Alright, so a lot of the mathematics has been done for you in this spreadsheet, so hopefully you know how to use this spreadsheet. Here's going to be the mass of Jupiter in solar mass units. Now these are solar mass units. We know Jupiter is smaller than the Sun, so these numbers better be smaller than 1. And in fact they are now, but even when you're done, they better be smaller than 1. Keep in mind, Each of these 4 moons is a scale measuring the mass of Jupiter. If you stand on 4 different scales, you would have the same rough mass on all 4 of them. So these 4 numbers here under the mass of Jupiter should be the same. And then you'll have an average down here. So again, I've reduced a lot of the math that you need to do for this particular lab by putting in this spreadsheet.